Good morning, fourth graders. Here we are, Unit 5, Lesson 7, and today we're looking at a lot of word problems. And you're going to need to be able to know what you're looking for, if you're looking for a bigger number or a smaller number, if you're using any conversions, if you're looking for perimeter, area, etc. So lots of stuff going on in these problems. Let's get started. Number 1 says, Ethan has 6 meters of string. He cuts the string into 3 pieces of equal length. How many centimeters long is each piece of string? Okay, so he has 6 meters and he cuts the string into 3 pieces of equal length. Now notice something right away, guys. We're going to put a box around units. That one says meters, this one says centimeters. So we're getting our information in meters, but we're going to have our answer in centimeters. You can decide if you like to do the math first and then convert to centimeters, or if you'd rather convert first and then do the math. I like to do the math first, and here's why. Usually if I do the math first, the numbers are smaller at first, just because they're giving me the smaller ones first in 4th grade, and then I convert. But you could always do it the other way as well. Just remember that there are definitely 2 steps to all of these. Okay, so he has 6 meters, and he cuts the string into 3 pieces of equal length. What am I going to do to that 6? Is it going to get smaller or bigger if he cuts the string? It's going to get smaller, right? So equal, we remember that is a very important word. It usually means multiply or divide. Now that we've decided that we're looking for a smaller number, I know that it must be divide. So I'm going to do 6 divided by 3 equals 2. Okay, now I'm going to make sure I write 2 meters because I have not converted yet. So I've got 2 meters there. And I know that each string is 2 meters long. But that's not the question. The question is asking how many centimeters long is each piece of string. There's a really handy chart that you can use. It is in your, it is on Google Classroom. I actually have a copy of it here that I'm going to show you. Mine is pink. And it's basically the same chart that we were seeing in our math books. But I wanted to show you this one because you'll see it in Google Classroom if you haven't already, and I just wanted to explain what's going on here. So you'll notice that there is a way to remember all of the prefixes in the metric system. King Henry died unusually drinking chocolate milk. It's a bit violent. You can make up your own if you don't like this one. Notice that the U stands for unit, and that's just our basic measure. So meter, liter, gram, just like we saw earlier in this math unit. And then we go to deci, centi, milli, deca, hecto, kilo. Again, this chart is really nice because it shows you that you're going to a smaller unit this way, but a bigger number. We saw those things in our book. And then the opposite. Look at this guy here. That's funny. Okay. The reason I really like this chart are the arrows at the bottom. Look at this. Divide numbers by 10 if you are getting bigger, as in getting a bigger unit, go that way. Multiply numbers by 10 if you are getting a smaller unit, or same as moving decimal point 1 space to the right. So you have this available too. If you have a printer, you can print this. It's really a handy dandy chart. Okay, so let's use our chart. We're trying to go from 2 meters to centimeters. So I know that I'm starting on meter, and I'm going to look before I leap. There's centimeters. So thinking about how many hops am I going to go from meters to centimeters? 2 hops, right? Good. Okay, so 2 meters equals, how many zeros should I put after the 2? 2 zeros because I had 2 hops. So 200 centimeters. Okay, so notice that I had to do the math of the problem and a conversion. Jamal put a cantaloupe with a mass of 450 grams in a bag. He adds another cantaloupe that had a mass of 485 grams. How many grams of cantaloupe are in the bag? Okay, so he had 450, and again, remember, I'm going to put rectangles around units. He adds another cantaloupe with a mass of 485. Again, luckily, it's still in grams. And then the question is asking us how many grams. Fourth graders, I think we got kind of lucky here. Look at that. Do you think that we're going to have to make a conversion? No, we don't have to. It's all in grams. So this problem will only have one step. What do you think that step's going to be? What are our clue words here? I see adds, which can be a really good clue word. Yep. And then remember that a lot of the times our curriculum doesn't say all together or are in the bag now, but if you're thinking in your head, oh yeah, there's two different things that I'm combining together, obviously I'm looking for a bigger number, a larger number. So I'm going to do 450 plus 485. This is a nice simple problem. I like it. And the answer to that is 935. Of course, you would need to make sure you showed your work and double checked yourself there. Okay, Tanisha has 35 milliliters of apple juice. She divides the juice evenly into 5 different glasses. Again, annotating my problem very carefully. I know you can't really do that on the computer screen, but you could still be thinking about these items. How much juice does she pour into each glass? Okay, ooh, there's another clue word there. So are we looking for a bigger number or a smaller number if she's starting with some juice and then she's dividing it into different glasses? We're looking for a smaller number, right? Do we have a conversion here? Do you think we're going to need our answer in anything other than milliliters? No, we do not. It doesn't ask like how many liters or how many centiliters or anything like that. It just says milliliters. So that's nice. We're going to take that big number 35 because we figured out that we have our big number and we want a smaller number. 35 divided by 5 equals 7. And then remember that for our, we can do ml there for milliliters for our abbreviation. Okay, so I want to choose one here that requires some conversions again. So the number 4 does. Catherine had a box of rocks that weighed 4 pounds. She put the rocks into 2 bags, each with the same weight. What is the weight of each bag in ounces? So we start with pounds here, but we're going to move to ounces. So really noticing those are different units, so we will have to convert. Again, I like to do the math first, and then I worry about the conversion. I think it's a good strategy. Okay, so we have 4 pounds. She puts the rocks into 2 bags, each with the same weight. Am I going to go up or down here? If she starts with 4 pounds and she puts some in one box and some in the other, I want a smaller number, right? Because I'm dividing it, hint, hint, dividing it into 2 boxes. Sorry, I think I said bags earlier. 4 divided by 2 equals 2. Okay, so remember 2 is in pounds. There's my abbreviation of pounds. It's weird. It's LB. Now I have to decide how to change pounds to ounces. Question for you. Will my pink chart help me? No, it won't, because this is the metric system. Pounds and ounces are not the metric system. They are the customary or standard system. Luckily, my math book is here to help. I will quickly go back to this page with, remember, the butter and the margarine. And how many ounces are in a pound? 16. 16 ounces are in a pound. So if I'm going from 2 pounds to ounces, am I going to have more ounces or more pounds? More ounces, because 16, right? 16 ounces are in 1 pound. So I'm going to take this 16 and I'm going to multiply it by the 2 that I have. So there's my 2. I'm multiplying it by my conversion number. 2 times 16 is 32, and now I'm in ounces. The abbreviation for ounces is OZ. Okay, so today's lesson will have a lot of word problems. I'm sure it'll take you through why you're doing what you're doing and those little drop down arrows that explain each step. Before you go though, we're going to look real carefully at the perimeter and area word problems because these are also going to be showing up. Let's look at number 11 together. The area of the rectangular sandbox is 32 square feet. Notice that they say it in square feet because it's the area. So right away we can be thinking about a rectangle. I love to draw pictures when I'm doing stuff like this. And I shade it in because I'm thinking, oh yeah, this is the area of that rectangle. So it's the inside, not the outside. So I already know, I'm gonna write 32 in there. I'm gonna write down what I know already. 32 is the area. The short side of the sandbox measures 4 feet. Okay, I can put that in there. How long is the long side? So thinking about what you're going to do with those two numbers. What do we know about area? We know that area equals length times width. That's our formula that we learned last lesson, right? So if I were going to substitute my numbers here, do I know what A equals? Do I know what the area is? I do. It's 32. 32 equals, do I know the length or the width? I'm going to say I know the width, so I'm going to put length there because I don't know that yet, times, and then the W equals 4. Don't forget this is an L. So 32 equals what times 4? What times 4 equals 32? That would be 8. So length is 8. Notice that these problems do go backwards because you're in 4th grade now, so they're not going to be the same as the ones you saw in 3rd grade where you just have to figure out the area or perimeter. There will be a lot of word problems where you have to decide, do you want a larger number, do you want a smaller number, and how can you get to the answers on both of those? All right, guys, don't forget that you have this great pink chart. You can take a screen grab right now if you know how to do that, or you can just go grab it from your Google Classroom. But I highly recommend having it handy for the metric questions.